In this video, we are going to look at the writing of isomers of a given formula. And in this case, as we mentioned before, that the longer the hydrocarbon is, the more isomers it will have. So given a simple example as the one shown here, it says C6H16 has several isomers. Write the structural formulas of each. Name each of by the IUPAC system. In working a problem such as this, proceed systematically by constructing the first heptane, then all the possible hexanes, then the pentanes, and so on. Then in the event that you should, by mistake, duplicate a structure, it will become more apparent when you start to name it. Duplicate names obviously become easier to spot than the duplicate structures. So the first thing that you need to do is, okay, fine, the first one is your most obvious one, which has got your the first one, which is your obvious one, has got a total of 7 carbons. So when you are going to represent that, it becomes a lot easier for you to just simply it becomes easier for you to state or to draw the carbon chain which shows the long chain of carbon atoms that are involved. Okay, so the first one, you would have your 7 carbons. So here's your 7 carbons. So just write it there. 1, 2, 3, 4, 5, 6, 7. So your 7 carbons, and each one would have the hydrogens there. Right, so on each you would have your hydrogens. On each carbon, make sure that each carbon is showing tetravalency. And so if you were to name this, the name would just be plain heptane. You'd look again and say, okay, fine, is it possible to put a substitute on any of the carbons? No, you cannot. If you're going to maintain the straight chain, you won't be able to have a chain longer than the 7. All right, so the next thing is to look at the next one, the next possible structure. What can you do? You can have a structure that has got 6 carbons. 1, 2, 3, 4, 5, 6. And then you can then now have an alkyl side chain that attaches. It cannot attach on the first carbon for the simple reason it will just become a continuation of the same carbon. So, but it can attach on carbon number 1 or number 2 rather, and then now you've got the side chain on carbon number 2. Right, so the rest of the molecule would remain unchanged, and you'll discover that the number of carbons also remains unchanged. You've got a total of 7, and you also have the same number of hydrogens in the molecule. So the long chain would have 1, 2, 3, 4, 5, 6. So your longest continuous chain is 6 carbons, so it's a hexane, but it's got a substitute group on carbon number 2, and that carbon number 2 is going to be a 2-methyl hexane. That is the thing. So it doesn't matter where you've got the substitute group, whether at the top or at the bottom, the structure is still going to be the same, right? So, and then the next item that you're going to look at is if instead of having that substitute group, the side chain on carbon number 2, you could actually even have it even on carbon number 3. So what you would then have is a structure that would look like this. I'm just going to copy this. Control C, and I'm going to paste it here, right, and then cut this. I'll cut that, put it on carbon number 3. Right. So now I now have my side chain on carbon number 3, and so if it's now on carbon number 3, it's the same long chain, which is 6 carbons, and so it's going, but it's now going to be on carbon number 3, so it's going to be 3 methyl. So, and then the next one, the next possible structure that I'm going to have is the next possible structure is now, instead of having a 6 carbon long chain, we can have 5, and then I can have a substitute group coming in onto carbon number 3 as well, and it would look something like this. Control C, Control V, just push it there, and then this here can then be cut. I can cut this here. Cut it, and then I can paste it here. Right, so now this would be on carbon number 2, and then the long chain would be having 2 methyl groups, so it's going to be 2 dimethyl propane, pentane rather, or I could move it to carbon number 3, and then on carbon number 3 I could then cut that, there, and also cut that, cut this and paste it here, and then now this would be on carbon number 3, and then this would be no, so that's 2,2-dimethyl pentane, which is fine. And then if I were to cut this here, that stays there, and then I need a duplicate of that. Control C and then paste it somewhere here. Right, so that can become another molecule, but with the shared or with the side chain at a different location on carbon number 3 now. So on carbon number 3 I would have that, and then cut that there as well, and then move that to carbon number 3. That's a single bond, and so this would be 3 dimethyl 3,3-dimethyl pentane. So when you look at all of this, just make sure you've got all your hydrogens in place. For all the whenever you draw a structure, make sure all your hydrogens are in place. So I left them out because it was for purposes of time, but you must make sure that all hydrogens are in place and that the valency around each carbon is 4. If you do not do that, you will lose all the marks that are associated with that. So here you would place all your hydrogens. May take time, but it's worth the effort. Hydrogen. So do it immediately so that you don't forget. Alright. When you look at all of these are possible isomers that can originate from a situation whereby you start off with C6, C7, H16. So just have a look. There could be some more. I could have left 1 or 2 out, but I think that should give you an idea of how to write the different isomers for the different substances that are there. Thank you very much for watching. I hope you liked it. If you liked it, please like, share, and send us your comments on the video.